bases. Okay, what are orthonormal bases? So the definition goes like this: consider an n-dimensional vector space V and the basis V1, V2, etc. to Vn of V. And the condition, first condition is if the inner product of Bi, Bj is equal to 0 for all I not equal to j, and the inner product of Bi to Bi is equal to 1 for all Ij equal to 1 to n, then the basis is called an orthonormal basis. So the first condition is orthogonality. If the inner product of two vectors are 0, that means that vectors are orthogonal. And if the inner product of the vector to itself is 1, means that norm of the vector is equal to 1, that is, it is a unit vector. So both the conditions are satisfied, it is called an orthonormal basis. And if only the first condition is satisfied, that is the first condition, the inner product of Bi to Bj is equal to 0, that means that they are orthogonal but not unit vectors. So we can call them as orthogonal basis. So for example, consider the Euclidean vector space Rn, where the inner product is the dot product. And consider these two vectors v1 and v2, and take the inner product of v1 and v2. We get it as 0, and find the length of v1 and v2. So v1 is v1 transpose into v, and it will be 1. Then in length of v2 is also calculated to 1. So that means that these two vectors, so these two bases v1 and v2 are orthonormal, since they satisfy the orthogonality property as well as they are unit vectors. Okay. Then we can use Gram-Schmidt process for finding out the orthonormal basis out of a set of basis vectors. So it is an iterative method to build orthonormal basis. So we assume that this is a set of non-orthogonal and unnormalized bases. So concatenate these vectors to form B cap. Okay, so all the basis vectors are concatenated into a single matrix. Then find the augmented matrix like this: B cap and B cap transpose and B cap. So we have to do the Gaussian elimination, and the final result will be the set of orthonormal bases. Okay, that's all about the